Hi, everyone. So this is Lazytest. This is talk about my standalone behavior-driven development testing framework. It looks like I left a framework off of that testing. So who am I? I'm Noah. I live in Northern Kentucky in the United States of America. As Master Shake says in Aqua Teen Hunger Force, I'm 30 or 40 years old. Been doing Clojure for a long time, and I'm currently working at a company called Relay Network out of Philadelphia. Um, so what else have I done? I've done Splint. Splint is a Clojure linter that's focused on style and code shape. It's heavily inspired by Rubocop, where it does parsing of the code as like in the AST instead of trying to evaluate it under some sort of context. And so it's very focused on kind of the Kibit. I don't know if you remember old that old library, line Kibit, and then Klein, which is the library that I gave a talk on a month and a half ago, 2 months ago. It's hard to remember. Time moves fast. Klein is an attempt to bring some of the configuration-based building and development workflows from Leiningen to Teps.eden and tools.build projects to kind of smooth over some of the boilerplate. That one's a lot of fun. It's very, very simple, very nice. So what is Lazytest? Lazytest is it's another test framework. It is a standalone test framework, so it doesn't rely on clojure.test. It is not interoperable with clojure.test. Lazytest attempts to start from scratch. It was originally developed by Sandra Sierra, who wrote the very first version of clojure.test back for Clojure 1.1. And when she wrote Clojure.test, it was as good as it could be for that time, and it worked well, and it got brought in out of the contribute library into Clojure core. But over time, she grew frustrated with it, and many people in the community have expressed over the last 15 years frustration with various parts of it. It could have been better. It could have been made different decisions, and now it's kind of for Clojure reasons, ossified. It's kind of solidified. Not much can be changed about it with breaking basically everything. So she started working on Lazytest, which was an alternative. And after about a year of poking at it, abandoned it. And so I came across the abandoned Git repo, the archived Git repo from 2013. I came across it a couple of years ago and really liked it. And so it is, as an alternative to clojure.test, it is an attempt to be both feature-rich and extensible compared to clojure.test. Clojure.test has extensible features, but they all kind of work against each other instead of together with each other in a couple of different ways. And so here's a picture of kind of what the code looks like. You have, instead of like a def test, you might say def describe, right? Using the behavior-driven development language, you have describe, you have it blocks, and you say expect. So expect is an assertion. And here we can see that you have a normal for loop, which might be lazy, but is eagerly consumed to generate expectations all at once, right? So this is generating, checks for x plus y versus y plus x, right? And it'll generate all of those and actually eagerly consume them. So what is wrong with clojure.test? Why do we need something like Lazytest? Well, there are a bunch of issues with it. The first one is that the is macro, the assertion macro is, tightly couples running the test code and reporting on it. Or I guess I should say that clojure.test in general tightly couples is with reporting on it. So instead of the is macro raising an asserting, x equals y, and then returning an object that a reporter can choose to report, right? It can call, print, or it can call log to an XML file, or it can call whatever. It instead, logs it directly. The reporter it calls the reporter directly and prints to the console, which means that it's not being tightly coupled means that you can't, or you're forced to work around things printing to standard out or standard error or whatever, instead of being able to make those decisions for yourself. Additionally, the primary function that's does the reporting is clojure.test report, and that's a dynamic variable, right? And so the idea is that if you redef it, you say, okay, for this run, I want to redef this to have some other printing system. That means that you're necessarily overriding any other user who is doing something interesting with Clojure report, right? Instead of it being like a multi-method or not a multi-method, it is a multi-method, but because it's dynamic, there's now an incompatibility where one person might extend it to do something cool, but then another person overwrites it, which happens with line again. Line again monkey patches clojure.test report, which leads to issues. Because tests are just simple functions, right? With metadata, where the assertions are all happening inside of the metadata. It's very hard to bundle them, right? So you might have or group them in different ways. The best that we can do is just put them into new namespaces, or we can give them metadata. But it's very hard to kind of like generatively create tests or check things. Testing blocks aren't real contexts. They're just strings. They're just dynamically held strings. And so as is assertions are happening, it's just grabbing the contents of the list in the dynamic variable testing or testing contexts or whatever it's called, which means that you can't select them, you can't skip them, you can't merge them, you can't do anything with them. All they are is dynamic strings. And then fixtures, while being helpful, they do have a helpful use. They are kind of inflexible and side effecting. You either say them they're for the whole namespace, right? And they're either going to be each or they're going to be every. And then that's it, right? It's like once or each. Once or each. And then that's it. That's for the namespace. They're side effecting. If you run them out of order, if you re-eval them, they can be attached multiple times. They're very messy. And so there's some other issues with clojure.test, but those are the big ones. Those are the ones that I feel really constrict what clojure.test can do. And there are a number of solutions for this as well. I don't want to act as if Lazytest is unique in this regard for attempting to handle some of these issues. There are other standalone frameworks, such as the original version of expectations. There's Midge, there's Speckle CLJ. Each of these is kind of like a differing solution to the problem of clojure.test not being sufficient. So expectations and Midge and Speckle each have their own assertion system, their own syntax. Like Midge uses the very awkward arrow syntax, where you say like X arrow Y. They all exist, but they all have their own separate issues, which is one of the reasons that I worked on Lazytest. And then, of course, there are the libraries, and this is only a small collection of them. There's many libraries that exist for clojure.test to help expand the scope of what clojure.test can do and what it's capable of doing. So there's, of course, line again. I shouldn't say everybody, but many people have used line again's built-in test framework, right? So it is built on top of clojure.test, and it has a test runner. It has a test selectors based on metadata. It has pretty printing. It does all sorts of stuff. There's Expectations v2, developed by Sean Corfield, which brings in the expect macro into clojure.tests and makes it work. So you can just say expect X, Y, and it'll do the equals or the comparison for you, submatching, etc. There's Coucha. Coucha is the really excellent Lambda Island uh, library, which does test running. It does and pretty printing, right? And so it has various reporters, various ways of printing the tests run as you do, and that is a magnificent piece of work. But it's built on top of clojure.test, so it is limited by what clojure.test is limited by in terms of its reporters, in terms of how it runs things, in terms of how it selects pieces. ftest, I don't have to go through all of these. Many of us have used these things, right? ftest is parallel testing. Magic combinators is a really great way of doing comparisons, right? Cognitech Zone test runner is like a really simple stripped down test runner. I guess I should say test finder and runner, right? It looks at a directory and selects them and then loads them. And there's many others, right? There's humane R output, which is a way of fixing clojure.test's R, etc. But they all like cover different portions of the issues that clojure.test has, and then don't cover other parts of it. And so my goal with what Sandra Sierra's goal, and then now my goal with Lazytest, is to shore up, is to find those pieces and kind of patch them and kind of provide a unified system, right? The classic XKCD of their 14 competing standards. We'll do the unification. Now there's 15. But I think what we have is pretty good. So what does Lazytest bring to the table? And I think these are the primary pieces that makes Lazytest worth looking into, worthwhile. So what we have is, compared to the other test frameworks such as Expectations, Midge, or Speckle, Lazytest is built on vars. So you are, like clojure.test, defining vars. This allows you to do REPL-driven development. This allows you to reload. This allows you to have specific names for things. I believe that names are good. Names are doc strings. And while doc strings by themselves can carry a lot more information than a name, I think that having a defined name, as we've seen throughout Clojure's history, vars are really, really nice. And having names for vars allows them to be used, grouped, called, etc., inspected. And that metadata, expectations as the only signal, clean separation for running and reporting, nested contexts as objects, and then multiple interfaces and reporters built in. So, as I was just saying, vars allow for REPL-driven development and make integration with tooling much easier. So in addition to the things I was just saying about REPL-driven development, I've found that a lot of the tooling that exists, CLJ Condo, Clojure LSP, even things like Eastwood, work best when there are vars to point to. When you can say, hey, this object has this doc string, it exists, it can be modified, it can be, you can say, go to the definition of. And this is something that clojure.test, I think, did correctly. Having vars and having vars as functions allows you to treat them like normal functions, like normal Clojure objects, and not as something magical. Whereas Midge or Expectations v1 or Speckle have they auto-generate. They use auto what do you call them? Gen sims, which means that you can't run them from the REPL. What you have to do is you have to have like a test watcher, right? You have to say like, hey, watch this directory and reload my code, which gets into the issues of component reloading and namespace graph reloading, etc. And that can get really messy. And so by having vars, we skip a whole set of problems, a whole set of bugs, which I think is a net benefit. This is the reason I put it at the top. I think that vars is something that every test framework should be using. And so then metadata. I meant to have a picture here, but I forgot. So metadata as a normal map. We talk about in Clojure having metadata and using metadata with the little caret and maps, and that can work pretty well. But one of the things that I really like about the defn form in Clojure is the attribute map, the attrs map that can be attached after the name, right? You say defn foo, and then you can have like an attrs map, and then the body of the thing, and that'll get attached as metadata instead of having to put it in front or above. And so one of the things that Lazytest does is it supports this, which allows for saying I want to focus on a given context object. I want to focus on a given section of the code, or I want to focus on a given assertion, and then it will narrow down and run only that one. Or you can say, I want to skip one, or I want to say this one is special. And then you can choose those things and run them specifically. It's really great. 3, exceptions as the only signal. Compared to, I think, almost everything else, Lazytest uses exceptions as the only way to know if a given assertion is true or false, right? So you say expect. When you say expect, if that is not true, it'll throw an exception, and then the test body will actually catch that and say, hey, this failed. And that means that it doesn't matter how far into the stack of your program an exception is thrown, it will catch all of them and it will mark them all. And there's no difference compared to clojure.test between a test failure and a test error, right? They are all the same. Everything is either an exception or not an exception. That might sound limiting, but what that allows us to do is define an interface for exception data, right, xinfo, to pass in meaningful information, right? The form that got thrown or the message that you want to say. It also allows us to define our own exceptions or exception throwing tests easily. Instead of having to define a multi-method like in clojure.test, you can have assert, the assert expr, right? There's a multi-method that allows you to say, hey, is this thrown, right? Or is this fuzzy equals, or in match combinators, you can say is match, right? With a little question mark. And that will actually grab the items and replace it with a different form where it will check the 2 items and then print something. Here, that can just be a function, a normal function that throws an exception, or a macro that throws an exception. And in throwing that exception, that will contain the line data, that will contain all the data that you need. And you can also just drop down to a normal assert. You can even say, hey, assert 1 equals 2, and that will work. And so that allows us a very wide flexibility in what we can support, what we can print, what we can display, without having to be opinionated about how we're going to print it or how we're going to display it or any of that. It's a separation between those things. Similarly, clojure.test and some of these other ones kind of, as Rich would say, complete running and reporting of the assertions. Running a set of tests and then reporting on them happens together, right? The is macro is calling report instead of passing the result of the assertion back to the body of the runner. And this also exists in things like Midge and things like expectations v1, where what we need to do is we need to have a context object. We need to have some method of saying, hey, there is a state that is being passed between all of these items, right? And the state, this like config or context, knows how to report things, but we leave it up to that to determine how we report them, how we print them, how we save them to a file, how we create them as JSON, etc., stream them, versus leaving that up to the assertion macros, to the exceptions. And by keeping those two things separated, that gives us a massive flexibility in determining which reporters we want to run. We can have multiple reporters combined at once. There are many different ways that we can kind of handle this, which is very nice. Number 5, nested contexts as objects. Instead of testing, as I said with clojure.test, instead of testing objects being just a dynamic list of strings, each of the kind of like describe blocks in Lazytest are comprehensive blocks. They create a function that is called, that builds all of the subpieces. And so then when we are actually filtering, we can step through and create basically a tree of everything that we're going to run, and then select which ones we want to run. Or we can filter them and say, I want to skip this one. I only want the integration ones. I want to have a before or an after happen here. So instead of merely having fixtures like in clojure.test, where it's one for the entire namespace or one for each def test block. Instead, here we can say, for this describe block, I want to have a before and an after. And then it will run before these things, then after those things. And you can have those as nested as you want, as far down as you want. And then the final one is that because of the way it's built, we can support multiple interfaces and multiple reporters. Now, you can do this as seen by the clojure.test library expectations v2. V2, allows you to have a def expect or an expecting instead of testing blocks, or the expect macro, which is the assertion, right? And those things are possible, but it's really nice, one, when they're built in, and two, when the interface is exposed enough that you can build your own pretty easily. And so built in, I've already defined alternative BDD style interfaces. So context instead of describe, specify instead of are it blocks, and should instead of expect. Pretty simple. But I've also built experimental interfaces to map to clojure.test. So you can write a def test and it will create a Lazytest version of a def test, right? So the def describe, as it's called. Interfaces for midge or QUnit and XUnit as multiple interfaces to show off exactly how they might work. And then the reporters that are built in, there are multiple of them. And so each of the reporters handles a different part of the reporting process, and they can all be combined. So you might want to have like the nested is the cool tree shape, right? So it shows you each of the contexts and each of the assertion blocks. The dots is just like in Coucha or in Mocha, where each of the namespaces is grouped by parentheses, and then each of the tests that happens is a dot, etc. All right, so let me show off. Let me show this off. Let me show off some of these pieces because we got some more time. Because I think some of this is perfect. So we're going to pull this right down here. All right. So let's show off an example. So here's what it looks like, right? This is the example from the picture that I took. So you might say, all right, here's a def describe. A def describe is a describe helper that assigns it to a var of the given name. So this is the plus example test, right? And so I can run it, right? I can say, hey, it's a success, right? And if I were to choose this to be 8, and I run it, oops. Oh, oops. Here we go. It says, hey, look, given any two integers, compute the sum of 3 and 4. Expectation failed. Plus 8. It's actually false. Here's the evaluated arguments, right? A total of 30 tests, 29 passed, and 1 failed. But I could also say, like right in here, I could say focus true. If I say focus true, focused tests only, and it selects just this one, right? And it doesn't run any of these. And so even if I were to change this to be foo, the only thing that runs here is this one right up here because I have focused it. Oh, I forgot to say that if anybody has any questions, please just I can't see the chat while I'm sharing. So I don't know, but if Alan wants to just say them to me,
yeah.
then I can answer them. So so we have this various metadata that we can select, right? And what's nice is that these things work very similarly. This works very similarly to how it works in regular Clojure, right? I can just have a let block here, and I can say, hey, the square root of 2 is less than 2, and it's greater than 1, right? It works. It works exactly as I expect, right? And here, because this is given example, you can see that this is just a normal var, and it has the doc string, right? We can attach a doc string to this var. It's very nice. Where's the other the context? So with this context, I can you can attach contexts to each of these describe blocks, right? So I might say before yeah. So I might say here, let's just create a new one. Def describe before test. So I can say describe the before context macro. Say it works. Expect equals 1, 1. Before I say print hello world. Oops. So here, or if we say print line inside, you see that it prints beforehand, right? I can do something arbitrary inside of this context, or I could even say after print line after hello world inside after hello world, right? So instead of being bound to a fixture, which can be of arbitrary, of like just top level only, I can arbitrarily nest these, right? I could even put this up here. So I could say it also works outside here. Expect to outline secondary. Hello world, inside, secondary, after hello world. Do you see that? And then this one can also have its own set, right? Say around F, print line F, then execute that F. Here we go. It prints the before block. It prints the context, right after, or I could even, here, let me, oops. Hello? Then I'm inside of this around block, just inside of here, and I'm printing the before, and then I'm executing the inside. I'm executing this as the function being contained by this around block, right? As fixtures work in clojure.test. The around blocks are basically fixtures, right? And then afterwards, I'm printing this, but also then I'm also printing this one, right? So here, and then to here, and then to here. And then outside of that, I've also got the secondary. And the secondary happens before this after block down there at the end. Marvelous. Isn't that so cool? This just works. It just works exactly the way that we would want it to work. And so this kind of stuff is possible because of the way that the runner is built. And these are predefined, but they can also be modified. And then likewise, if we wanted to run some of the different reporters, let me show off. Let me this file test. Just run this instead of using. So you say like clojure.test output dots. Let's turn that one off. These dots here are determined by this thing, right? By just choosing from the outside. So I can go to the reporter and say, hey, look, there's all of these reporters that we have here. We have focused, we have the summary prints just this thing. And it's defined to do nothing. By default, the summary does nothing. But at the end of the test run, it takes the results, which is a list, a tree of all of the things that happened, right? And it's able to summarize all of them. And then it does some math on them, and then it spits out, it decides to print the summary, right? But I could also say quiet. Quiet does nothing, except for, of course, giving me the output. So this might work if this is in CI, or if this is part of a larger script, right? That you only want to run just these things, right? And so each of these is determines exactly how it works. If I want to have a profile, I could say this dots and output profile. These can be seamlessly combined like in Coucha, where it will run them in the order that I've specified. It will combine them. So here we go. It runs the dots, and then it also runs the profile. And the profile here shows me the top 5 slowest test namespaces, and also the slowest 5 test vars, right? Which is pretty great. It's pretty miraculous that I can do this. And all it takes is writing another multi-method, which anybody can do. And so modifying this is as simple as including these things in your configuration, right? What's the other? I showed off the metadata, showed off the vars, showed off the pretty printing. Interfaces. Yeah, let's show this off. And so actually, let me do the match. Let me do the match your combinators. So I want to show this off lastly. I've been talking for a little while. So match your combinators is a wonderful library by is it who is it? Is it Nubank? I don't remember where Magic Combinators comes from. Yeah, it's Nubank. Magic Combinators comes from Nubank. It's marvelous. It checks the sub objects against each other, selecting for them. And so writing a new match, like a new entry in for Lazytest is as quote unquote simple as writing a macro that just calls those things by themselves, right? And then throwing like the given x failed, which is kind of like an x info for the form that you have, plus what you expected to have happen, right? So you could say, hey, if there's a match, um, let's check them against each other, and if it's not a match, then we're going to throw, right? We're going to throw the form, we're going to print the actual, etc. And so that allows you to just write very easily, hey, I want to match against these two things. And this will expand intelligently into the right calls. And then this expect here will catch it and actually check them against each other, right? And so we don't have to do any of the assert expr stuff. We don't have to do any printing. Here, there's no printing involved. I'm not printing to standard out. I am not printing to standard error. I'm not messing around with strings at all. What I'm doing is I'm presenting a message and then the evaluated and the actual forms, and I'm throwing those. And in throwing those, the test body, the test block here, will actually catch, the test case will catch these assertions, right? The thrown object from expect, and catch it, and then do the printing for me. And it will do the printing purely based on the reporters that I've given, right? I chose dots, so if this is 2, when I, right, it says, hey, look, there was a failure here, and I'm going to only show you, the output of where it failed in Lazytest, Match Your Combinators test, line 11. Hey, look, that's line 11, right? I realize that I'm parroting what clojure.test already does, but the output is happening well after the printing is happening well after this is done, right? You see that this prints out one piece at a time, and says F, and then only at the very end does it print everything else, right? Because the runner is building a tree, basically a graph of all of the things that's running and holding on to them as data, and then the printer is stepping through, basically doing what is effectively a walk of that graph and printing out based on the contents.